So now we have defined all our input and output. We can start writing down the ladder diagram. Okay, so say I want to start the system. Okay, so I have a momentary start here connected directly with a move 0 to sorry, not move 0. We're not initializing, we're putting 1 inside the register. Sorry, CH0. Okay, here, and then straight away we will initialize the register. So okay, excuse my drawing here. So SFT H0 H0. So the way we write this, because we want the shifting to be internal, and then we have, like I said, a working bit to make sure that the shifting happens, and then the stop button to reset. Okay, so here it's 0.00, stop here is 0.01. Okay, so enough with initialization. Then we will do the condition for each of the steps that it needs to be shifted. Okay, so the first step is H0.00 with the stamping sensor 0.02, and then it should shift 2.0. Okay, so ideally this should be the line, but then in practical we put the 0.02 second flag, which turns on every 0.02 second, to make sure that the condition is given a pulse, okay, instead of always on condition. Okay, so this is considered a practical solution to give the condition to shift the bit. Okay, all right, so that's the first step. The second step is H0.01. We should wait for the timer. Okay, say the first timer is labeled T.00. We haven't yet declared the timer. And then the third one is labeling sensor. Okay, and then the fourth one is the second timer at the labeling, and then the fifth one is the packaging sensor, and then the last one is the timer for the packaging. Okay, all right, so this is the condition for the shifting. So basically now we have take into consideration all the shifting condition. Now we want to look at the output. Okay, so obviously when we start, okay, H00 is on, so H00 directly turn on the conveyor. Okay, so conveyor is on. Right, now when it shifted to H01 0.01, it turns on the stamping cylinder. Okay, stamping cylinder, so stamping cylinder is 100.01. Okay, and at the same time it should turn on the first timer. Okay, so the first timer, say 5 seconds. Okay, then after it shifted to the second one, okay, so remember, if we take a look at the output, when the first bit is shifted, okay, to the second bit, okay, so H00 now becomes 0 and H01 becomes 1, we know straight away that the conveyor will be off. Okay, so the next step is when the timer has finished counting, Okay, remember timer 00. When the timer is finished counting, the conveyor should start again. Okay, so if the conveyor should start again, then H002 is obviously not here. H002 must be here. Okay, because we need to start the conveyor again. Right. So the conveyor should be on until you reach the sensor. Okay. So right now, there is not out. What the output involved is only conveyor. Okay. Then when it shifted to the next bit, H0.03 will now activate the labeling cylinder. Okay. And also at the same time, activate the timer for the labeling. Okay, so we can see now here is that as long as H0.03 is on, you can see that the cylinder is on, so it will keep on labeling for 5 seconds. Sorry, for 10 seconds. So once the timer is finished counting, okay, we will shift to the next bit. Okay, so when we shift to the next bit, what happens here is that instead of other output is on, it will on the conveyor again, right? So then we will put the OR here for the conveyor, because now remember that 0.00 and 0.02 is already off. Okay, so now we need to turn on the conveyor again. So we put H004 for the next bit, we'll turn the conveyor on. So when it reaches the packaging sensor, obviously it will shift to the next bit, which is H0.05, and when it reaches there, it should activate the packaging sensor, and also at the same time the timer. Okay, for example here is 150 for 15 seconds. Okay, so when that happens, okay, it will wait for the timer to finish. When the timer is finished, the whole rung is laid on, and then it will shift the register to H006. Alright, now the step is already finished and we want to look back. So what we do, because the next move is H0.06, we will put H0.06 here. Okay, because when we move to H0.06, it will turn on here and obviously copy the one bit again to the least position, and then we will loop the whole thing. Okay, it will go on and on again. So this is how we solve the second question. I know it's quite long, and basically we are considering these two questions together is because Dr. Faris has already taught you shift register and already give you the assignment on basically, I think, quite similar, very, very similar to this question. So if you have done your job or you have done your work, then this is basically a piece of cake. Okay. All right. So if you have problem doing this, and obviously it's not because you're dumb or you cannot understand the question, or you don't have the idea for the answer. It's simply because you do not practice enough. Okay, so please practice on your on the solution of the problem to give you some kind of a programming mindset for the for both of the for the solution of the problem using PLC. And you can see that for the math side that you solve for the first question, and the second question is the mindset of solving the problem is quite different. With shift register, it is important that you outline the step first, and then make sure that what you know what start and end each of the step for that step to be coded inside the requirement here. Okay, and you have to also understand the activation block. Okay, what will be on immediately after the register is on. Okay, each bit of the register is on. Okay, so I think that's it.